here. We'll go from, even with the transmitter, to the bottom of the tank. And if it's 10 inches tall, and we have the same specific gravity, we have the same liquid inside this line here, we still have to account for that liquid, that hydrostatic pressure that's being applied to the transmitter. So on our 4 milliamps, we're going to use this electronic one, 4 milliamps on the low side would be 0 inches of water column, because we're looking at the difference in pressure again. If we have 14.7 here and 14.7 here, they null each other out because that 14.7 is also being applied here. So this is a difference of 0 inches of water column. Now, when we go to get our 4 milliamps, in this instance, in this example, we have to account for this 10 inches. So if we multiply 10 inches times 1, we will have 10 inch of water column pressure applied here, and that would be our 4 milliamps. I'm going to erase this transmitter so I can go ahead and finish out this little chart. Transmitter's still mounted there, I just had to get rid of it. So this is, if we were bench calibrating this transmitter, and we would sit down and we would apply 10 inches of water column pressure to our high side, and we would set our 0 for 4 milliamps out. And then if we want to set our range for 100 to get our 100% value, we would have to account for this height plus that height. So now we have 110 inches times 1. On the low side, we still don't have any differential. We're still vented to atmosphere. So we're still going to have 0 inches of water column here. But on the high side, we have to account for this plus this. So we're actually going to apply 110 inches of water column on our high side of that transmitter to set it up for this application. It could be that you have the transmitter mounted below the tank. It could be that you have the transmitter actually mounted at this point, but you want your 0% at this point. You want it above the bottom of the tank. Anytime that your 0 percentage, your 0 level is above where the transmitter is physically mounted, that is an application of suppression. It could be 10 inches. We had the transmitter mounted here. We only went up 10 inches to the bottom of the tank. We nulled that part of it out. We suppressed that amount of pressure out of our 0 setting, but that's still an example of 0. On a Rosemount 1151, there's a jumper on the card that has an SZ and an EZ on it. There's a 3-position jumper on there. The only instance, or when you have to move that jumper, is when you're trying to suppress about 50 inches of water column out of your 0 setting. In that application, you're actually going to have to change the circuit on that board to accommodate for that, to allow you to 0 out that much pressure on our transmitters. This is level suppression, or this is level detection using hydrostatic pressure only. Next time we will go over elevation, which is a closed tank application, and there's a little bit more math involved in it, but we're just simply multiplying. We're adding and we're multiplying. It's a very simple operation. If you put your numbers down, your calibration values in a form like this, it's going to be very easy for you as you're going through your calibrations to find out which numbers that you actually use to calibrate it, instead of having things all over the page or all over the board where you start working these problems and it's like, oh, I have one number over here and I have a number over here. Be methodical. Be, oh my gosh. Have it organized. Have everything organized to where you don't have to guess, where did I put my 0 setting, or where did I put my span calculations? And then you go and grab the wrong one and you don't calibrate your transmitter correctly. Be organized. This will organize any kind of math that you have to do, and you put it into that form. It will help you out.